Hello everyone. This is Sudhanshu Sarkar, Assistant Professor, Department of Electrical Engineering, Narula Institute of Technology. Today I'm going to talk about a topic of switchgear and protection. This is one of the vital subjects for electrical engineers, and this subject is model designed for the diploma third year students. Now, this is the lesson plan. In Unit 1, we have the fundamentals of the switchgear and protection. Then in Unit 3, protective relays. Then in Unit 4, there are different types of protection, like different types of equipment protection. So today I'm going to talk about the protection of busbar. So here today's topic of discussion is the protection of busbar, or you can say the busbar protection. Now this is the content for today's lecture. So first I will talk about what is the busbar, then causes of fault, that what type of fault occurred in case of busbar, then the suitable protection, that what type of protection we can take to protect the busbar from the fault conditions, then the selection of CT ratios. After that, I will talk about the types of faults, and then finally overcoming the faults, that how can we overcome from this fault, and finally we will talk about the conclusion part. So this is the contents for today's lecture. Now, first let me talk about what is a busbar. So the word busbar derived from Latin word omnibus. Omnibus means, in English, it is common for all. That means the busbar is basically the nerve center of power system where various circuits are connected together. Okay. So various circuits are connected together with a particular nerve center of the power system, that is called the busbar. Now, I think all of you are well aware that there are three types of busbar in the system. One is slack bus, one is PV bus, and one is PQ bus. Slack bus means the maximum generating bus. The voltage of the slack bus is 1, and the angle of the busbar is 0 degree. The voltage is 1 per unit. Then PQ bus, second type of bus, and PQ bus is also called the load bus. So for PQ bus, we have to find the voltage and angle, and the P and Q is always will be given in the system, and PV bus is actually the voltage control bus. So PV will be given, and Q and delta we have to calculate from the PV bus. So three types of bus, four types of variables, P, Q, V, delta. So two variables are known and two variables are unknown. So with different types of load flow studies and calculation, we can find the data from the bus bar. Like for slack bus, the specified values are V and delta, and the unspecified values are P and Q. For PQ bus, P and Q are specified, so unspecified is V and delta. For PV bus, P and V is specified, and Q and delta are unspecified. So we'll talk about this on in some relevant topic or relevant subject. So that is the basic concept about the bus bar. Now, sometimes you know that in all the section of the electrical system or power system, the fault may occur. So you have to understand that what is the causes of this type of faults. Now, breakdown of insulation because of over voltage, foreign objects, etc., is one of the cause of the fault. You know that breakdown of insulation. So insulations are connected through the busbar or through the transmission line, and you will find it in the generating station, you will find in the substation. So insulation breakdown is one of the reasons. So why this insulation is breakdown happens? Because of the over voltage, and without this some of foreign objects, so for any weather related issue or any something like the different types of problem you can find in the environment. So for that, the sometimes the insulation may break down. So these breakdown of insulation because of overvoltage and foreign objects, etc., are the cause of one of the fault. Next, second one, weakening of insulation because of aging, corrosion, salty water, etc. So for these reason, the insulation also break down sometime or it becomes weak. That's the main or the fundamental causes of the fault. Now the suitable protection, that but what type of protection we can provide for this busbar? So the most important protection is the differential protection. Now the question is, why differential protection? There are so many protection you already learned. I already uh, give the lecture on the different types of protection on this switchgear and protection chapter topic. So the question is, why this for busbar protection, why this differential protection is required? Number one, terminals of the system are near to each other. Okay, so for that reason, the differential protection is required. Terminal of the system are near to each other. Number two, so this is number one. Number two is, hence, by installing CTs, current transformer, on the two sides of the bus, comparison can be made between the current entering it and leaving it. Okay, so you know that in differential protection we can connect CTs in both sides of the bus. So installing or connecting CTs on the both side of the bus, we can compare the what is the current, which amount of current is entering and leaving from it. So that is one of the reason of the differential using the differential protection. Any difference in current will immediately signal an internal fault. So if any difference is there, that is actually the property of the differential protection. So using the property of the differential protection, we can identify the problem between the signals with the help of the immediate signal. Because we know that if there is any difference in the current, will immediately signal an internal fault. Now, number two is completed. Number three, the difference in current can be used to excite the coil of a differential relay via CT secondary, that means the current transformer secondary, and thus issue trip commands to circuit breaker CB on both sides of the bus to isolate it. So this is the third reason that why we are using this differential protection. Now here, if you follow this figure, you can find that a wrongly method of CT ratio selection. Why this is called the wrongly method of CT ratio selection? Because if you follow, you will find that here the ratio is 1000 by 1, here 3000 by 1, here 2000 by 1. Okay, circuit breaker. So current entering is 1000 and the output current is 1. 3000 ampere. Yes, so here the value of the CT ratio is not same in all the areas. So what is the problem? The problem is, look, that means the method of selecting CT ratio on the basis of the maximum primary current seen by individual feeder is not correct. So for that reason, we are considering the previous figure that the CT ratio selection is not correct. Now, the correct method of CT ratio selection. So what is the correct method? Now try to understand it. The correct method here 3000 by 1. Here also 3000 by 1. Here also 3000 by 1. But previous cases for incorrect 1000 by 1. Then it was 3000 by 1. It was 2000 by 1. But here look, if you follow, the correct method of CT ratio is always the same. Okay, so why it is? Because CT ratios for all CTs in bus differential schemes is maximum output. So this is the reason that the maximum output of all the feeder currents divided by 1 ampere or 5 ampere. So this is the CT ratio for all CTs current transformer in bus differential scheme. So you have to remember this one. This is very important. Maximum output of all the feeder currents by 1 ampere or 5 ampere. Now, types of faults. So what are the different types of fault you can find for the busbar fault, busbar protection? So the fault you will find, the faults may be broadly classified as external fault, through fault, and internal fault. So you will find broadly two types of fault basically. So first one is the external fault and the second one is the internal fault. So these are the two types of fault you will find for the busbar protection. Now, requirement of a unit protection is that the differential scheme should respond to internal faults and should not respond to external faults. So these are the faults of busbar protection you will find. Now, the internal fault. Look here, internal fault happens. So in this area, internal fault occurs. So and the current value is here after the fault is 30,000 ampere. So and this is the external fault. So the fault occurs in this area for these external faults. So how it looks like, this is the external fault. So in this area the current is 30,000 ampere. This is the external fault and this is the overall circuit diagram. Now look here, the maloperation of busbar differential scheme on external faults is caused due to non-ideal behavior of CT carrying excessive primary current during fault condition. Okay, so what is actually this? Look, you need to remember that the maloperation of busbar differential scheme on external fault, okay, when on external fault is caused, why it is creating, due to non-ideal behavior. Okay, non-ideal behavior of CT carrying excessive primary current, okay, during fault conditions. So need to remember this part. Now the correction method, that how can we correct this from this problem, or how can we overcome this fault. Due to external fault, one of the CTs gets saturated. Okay, so what happened, when due to external faults one of the CT's current transformer gets saturated, the differential relay coil needs to be restrained from tripping. Yes, so this is the correction method. Now in the second part you can follow that you can easily accomplish this by connecting a higher resistance known as stabilizing resistance in series with the differential relay coil. So you have to understand, you have to know that how the differential relay operates. So on the operating principle, we can apply the operating principle of the differential relay. We can correct, we can understand that how this problem we can solve. Now, so here we can easily accomplish this by connecting a high resistance known as stabilizing resistance. This is known as stabilizing resistance in the series with the differential relay coil. The next one, if you try to understand, you will find that it will be clear to the stabilizing resistance. The stabilizing resistance should be of such a value that under the worst case of maximum external fault and full saturation of CT, the current through differential coil is less than its pickup value, and at the same time it should respond to minimum internal fault current. Okay, so in this way we can correct, or we can solve the problem of our busbar protection. Now, dot convention, it's a very important convention for the measurement of fault and for the protection purpose of the bus bar. The dot convention and the dot marking are used to know the direction of circulating current in the current transformer secondary circuit. So dot marking are used. Why it is used? To know the direction that of circulating current. So dot convention basically uh, helps us to find the direction of the circulating current in the city secondary circuit. Now the second one, rule of dot convention says that when current enters the dot mark on the primary side of the CT, the current must leave the similar mark, dot mark, that is the dot mark on the secondary side, and vice versa. So this process, with the help of this method, we can understand, it will help us to find out the problem. So this is actually the dot convention of a Busbar protection system. Now, why now PS class only? Why PS class only? You know the word PS class. Oh, and let me talk about the PS class. Why this PS protection class? CTs current transformers such as P 5P10, 5P20 may produce undesired difference current in the CT secondary due to following reasons. Two or more CTs of class 5P10 may have different accuracy. In this case, for 10 times the rated current. Okay. Second one, even if the CTs are identically manufactured, deterioration of core properties over time may differ, and they may behave differently over time. So these are the two reasons why PS class only. So first one is this, cities of class 5P10 may have different accuracy. So what is the accuracy? In case of this, 10 times of rated current. And the second one, even if the cities are identically manufactured, deterioration of core properties over time may differ, and they may behave differentially over time. Now, number three is distance of incoming site CT and outgoing site CT may lead to difference in lead length, thus imposing additional burden on cities, which may in turn shift the saturation level of the cities. Owing to many other similar factors contributing to maloperation of unit protection schemes, when conventional protection class cities such as 5P10 are employed, usage of special protection class cities are known as PS class become popular. So here the features of PS class. So here, instead of generalizing minimum saturation level of the CT, the user have to exactly specify the saturation level of the CT. This is called as knee point voltage, as it appears as a human knee in CT magnetization characteristic. These specification will take into account the maximum through fault current, the actual lead burden, the relay burden, resistance of the CT secondary winding, and also a factor of safety. Now, in the conclusion part, we can say that thus it is concluded that the bus bar protection is an important part of power system. Yes, obviously, because bus bar has a great role to flow the power in the for the system. As the system voltage has been increased and short circuit capacitance are building up. Okay, so it is not advisable to leave the bus bars unprotected on a primary basis. So we cannot leave the bus bar in unprotected in the primary basis. So for that reason, the bus bar protection is one of the most vital and one of the most important part for the electrical power system for the safety purpose of the whole system, because the power flow, the voltage stability, the voltage injections, the load flow, the everything, the demand, everything is depending on the bus bar, because with the help of this bus bar, all the equipment are connected from the generation part to transmission, from transmission to distribution, and distribution to the consumer ends. The whole system is connected through the bus bar. So bus bar has a great role, important role for the system. For that reason, it is very important. Now, the reference, so here to make this video or PowerPoint presentation, I take help from the Fundamentals of Power System Protection by YG Pythankar and SR Vinde, and also I take help from the google.com, www.google.com. Thank you all. Thanks for watching the lecture.